Hello. In this video, we're going to find where f is increasing and decreasing if f of x equals 2x plus 4 to the 2/5 power, and then we're going to graph the function using the calculator. Okay, so to do this, we first want to find where the function is increasing or decreasing, but to do that, we need the critical numbers. To find those, we need to find the first derivative. So to do that, bring the 2/5 down in front, then rewrite the parentheses, because we're using the chain rule here, and then subtract 1 from the exponent. 2/5 minus 1 is negative 3/5. And then multiply by the derivative of the inside. The derivative of the inside, well, the derivative of 2x is 2, and the derivative of 4, well, the 4 goes away, so there we go. We just have 2. So 2 times 2, that's in the numerator. That's going to give us 4. But notice that the exponent is negative, so that makes a 5 times 2x plus 4 to the positive 3/5 power in the denominator. So there you go. We have f prime of x is 4 over 5 times 2x plus 4 to the 3/5 power. So to find the critical numbers, we set both the numerator and denominator both equal to 0. So that's going to give us 4 equal to 0. And then 5 times 2x plus 4 to the 3/5 power is equal to 0. Now notice that the first one doesn't give us a solution, so it doesn't give us any critical numbers. The second one, though, we divide by 5, so we get 2x plus 4 to the 3/5 power is equal to 0. And that means I can take both sides to the 5/3 power, and that's going to give me 2x plus 4 is equal to 0, which means subtract 4. 2x equals negative 4, and divide by 2, so x equals negative 2. And there you go. So we have a critical number. It's x equals negative 2 if it's part of the domain of the original. Now if I plug this in, 2 times negative 2 is negative 4. Negative 4 plus 4 is 0, so all that's 0 to the 2/5 power, and that gives me 0. So this negative 2 is part of the domain of the original function, therefore it is in fact a critical number. Now, that means that we can go ahead and look at the number line, and I can break it up at negative 2. But that means I want to choose an x value in that region and plug it in to the f prime. And I want to know, is the derivative positive or negative there? Well, to the left of negative 2, remember, it's already negative, so go more negative. So to the left of negative 2, let's just say negative 3. If I plug that in, 2 times negative 3 is negative 6, plus 4 is negative 2. Negative 2 to the 3/5 power is still negative, that's all we care about. Negative times a positive is negative, positive over negative is negative. The entire thing here is negative. That's the important thing here. Now, to the right of negative 2, well, my preference is always 0, if we can. 2 times 0 is 0. 0 plus 4 is 4. That's positive. Positive to the 3/5 power is positive. Positive times a positive. Positive over positive. We're just all positive here. We're positive people. What can I say? There you go. And so that tells me that this function is decreasing to the left of negative 2, and it's increasing to the right of negative 2. So we have increasing when we're to the right, which is from negative 2 to the infinity, and it's decreasing when it's to the left, which is negative infinity to negative 2. Awesome. Well, at this point, all we really need to do is graph the function, which I'm going to do in the calculator, so I will see you there. Okay, welcome to the calculator. Let's type this in on y equals. So we have 2x plus 4, close parentheses, raised to the 3/5 power. Nope, sorry, 2/5 power. My apologies. And then graph it. So there you go. Notice it's much like the previous video. It's decreasing over here, and then it's increasing over here. I'm curious what would have happened if this was to the 3rd power instead of to the 2/5 power. Yeah, that's what I thought. It's continuous everywhere. Now notice that this actually is, we would still have an undefined value at x equaling negative 2 if this happens. but that's for the derivative itself. So the derivative is not actually defined at x equals -2 still. But notice it's not because there's a sharp edge, it's because the tangent line happens to be vertical there. But notice that as a result, that actually doesn't change anything. This goes from positive to positive, so they're both positive it's positive on both sides here. That's only if it's to the 3/5 power, not to the 2/5 power. 2/5 power, it is decreasing followed by increasing. By the way, notice that as a result, there is a minimum point that's happening here. Alrighty. Well, I believe that's it for this video. I'm going to go ahead and end it here, and I will see you in the next one. Have fun.